Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring algebraic expressions. We will learn how to evaluate an algebraic expression and how to simplify an algebraic expression. Before we start, let's look at some definitions. An algebraic expression consists of numbers, constants, variables, and operation symbols. For example, 4x plus 2 is an algebraic expression. Notice one thing an algebraic expression will never have is an equal sign. If you have an equal sign, then you have an equation. This is just an expression. Another example might be 3x squared plus 1 or 2 pi r. These are all examples of algebraic expressions. Now, algebraic expressions are made up of terms. Terms are individual variables, groups of variables, and or numbers which are separated by addition or subtraction. In example 1, it says state how many terms each expression has. So in problem A, we have 4x minus 9y. Now we have a subtraction sign, and so we have one term here and one term here. So this expression has two terms. Problem B. Again, our terms are separated by subtraction. So we have one term here and one term here. So this problem also has two terms. Now, in the next problem, we have addition and subtraction. So we have one term here, one term here, and one term here. So this expression has three terms. Pause the video and try problem D on your own. All right, did you notice that problem D does not have an addition or a subtraction symbol? That's because 4x squared y is all one term. So check your answer. Now, with algebraic expressions, one of the things we can do for them is to evaluate them. When the value of a variable is given, we can use a process called substitution to find the value of the algebraic expression. For example, if I have the algebraic expression 2x plus 5, and I'm given that x equals 3, I can evaluate that expression by replacing the variable with parentheses and then substituting in the value that they give me. After you substitute the value in, then you just use the order of operations to simplify. So 2 times 3 is 6, 6 plus 5 is 11. All right, in example 2, it says evaluate each algebraic expression for the indicated value of the variable. Show your substitution and be sure to simplify all fractions to lowest term. So in problem A, our expression is 1/2 x plus 4. And in this problem, we're given that x is equal to 6. So your first step is to replace the variable with parentheses. So instead of 1/2 x, you'll put 1/2 parenthesis plus 4. Your second step is to substitute in the given value. So I'll substitute in a 6. Now your next step is to use the order of operations to evaluate. So 1/2 times 6 is the same thing as 1/2 of 6, which is 3, and 3 plus 4 is 7. So the value of 1/2 x plus 4 when x equals 6 is 7. All right, problem B. Evaluate the expression 8 minus 3x for x equals 5. So step 1, replace the value of the variable with parentheses. Step 2, substitute in the given value of x. Step 3, use the order of operations to simplify. Now here we have 8 minus 3 times 5. So according to the order of operations, we want to multiply first. So 3 times 5 is 15. So this would simplify to 8 minus 15. Now 8 minus 15 would be negative 7. 7. Problem C. Evaluate 3s squared for s equals negative 3. So 3 parentheses squared, substitute in negative 3. Now evaluate. Now, in the order of operations, we do the exponents before we multiply. So I want to figure out what is negative 3 squared, which is the same thing as negative 3 times negative 3, which is positive 9. So this is 3 times 9. And then evaluate that. 27. So always be sure to follow your order of operations when you're evaluating algebraic expressions. Now, another thing we can do with algebraic expressions is simplify them. Algebraic expressions are considered simplified when all parentheses have been removed and all like terms have been combined. So let me just remind you what a like term is. A like term must have the same variable raised to the same power. So for example, 8x and negative 2x. Those are like terms because they have the same variable and the same power. Okay, 3x squared and 4x squared are like terms because they both have an x squared. But if I were to have this 8 and 4x, those are not like terms because the 8 does not have an x on it. In example 3, it says rewrite each algebraic expression as a monomial. Now, a monomial simply means an expression with one term. So don't get hung up on the language there. It just means we're going to have one term in our final answer. So in problem A, we have the like terms 5r plus, and if it helps you, put a 1 right there, 5r plus 1r, and that would give you 6r. Do not change the power when you're combining like terms, all right? In problem B, we have 5x minus 2x, and that would simply give us 3x when we simplify it. Number 7, we have negative 8m minus 2m. Remember, when the signs are both negative, you add them together, so that would give you negative 10m. All right. Now, let's look at expressions that are a little bit more complicated, and we're going to use the same process to simplify them. So in example 4, it says simplify each of the following by combining like terms. So we have 10x plus 5 minus 3x minus 7. So what we're going to do is we're going to put our like terms together. So we have 10x minus 3x. Those like terms can go together. Plus, and then we have 5 minus 7. Those like terms can go together. Okay, so 10x minus 3x would give us 7x. 5 minus 7 would give us negative 2. Now, don't leave your answer like that, because what you have here are double signs. You have a plus and a negative. You want to rewrite 7x plus negative 2 is the same thing as 7x minus 2. So don't leave double signs in your answer. Okay. Problem B, 6m minus 2 minus 4m minus 12. So in my first parenthesis, I'll put 6m minus 4m. In my second parenthesis, I'll put negative 2 minus 12. All right. So 6m minus 4m is 2m. And negative 2 minus 12 is negative 14. But remember, we don't want double signs. So 2m plus negative 14 is the same thing as 2m minus 14. All right. Problem C, 8 minus 3y minus 10 minus y. So in my first parenthesis, I'll put negative 3y minus y. And in my second parenthesis, I'll put 8 minus 10. Now, it may help you if you'll put a 1 in front of this y. So negative 3y minus 1y. They're both negative, so that means we're going to add them together to get negative 4y. And 8 minus 10 is negative 2. but I want to rewrite that. Negative 4y plus negative 2 is the same thing as negative 4y minus 2. All right, problem D. Negative 10c plus 20 minus 4c minus 3. So I'm going to put negative 10c minus 4c together in the first parenthesis. And I'm going to put 20 minus 3 together in the second parenthesis. So negative 10 minus 4 would be negative 14c. And 20 minus 3 would be positive 17. Now, I don't need to rewrite this one, because we don't have double signs. All right. Problem E. 3n plus 18 minus 5n minus 6. So I'll put the 3n minus 5n together, and then I'll put the 18 minus 6 together. So 3n minus 5n would be negative 2n, and 18 minus 6 would give me 12. This does not need to be rewritten because I don't have double signs. All right, problem F. X minus 8 minus 4x minus 2. So my first parenthesis, I'll put x minus 4x. In my second parenthesis, I'll put negative 8 minus 2. It may help you to put a 1 right here in front of the x. So 1x minus 4x would be negative 3x. And negative 8 minus 2 would be negative 10. Now here I have a plus and negative, so that's a double sign. We need to rewrite that as 3x minus 10. All right, in problem G, we have a kind of a complicated problem because we have a lot of subtraction symbols. So one thing that you can do to help you when you have these subtraction symbols is change everything to addition of the opposite if you want to. So negative 3a plus negative b, and then plus positive 6c plus negative 2a plus negative b plus negative 2c. So I just changed all the subtraction symbols to addition of the opposite. All right, now I'm going to put the a's together. Negative 3a minus 2a. I think that's the only a's I see. Now I'll put the b's together. Okay, negative b plus negative b. Now I'll put the c's together. 6c minus 2c. All right, now combine each one of those. So negative 3a minus 2a would give me negative 5a. Negative 1b plus negative 1b would be plus negative 2b. 6c minus 2c is positive 4c. Now the only thing I need to rewrite is right here in the middle. We have plus and negative, so we've got double signs there that we need to fix. So this would be negative 5a minus 2b plus 4c. Now we have it rewritten properly. All right, now let's look at problem H. We have 16 plus 5x minus 10x minus 22 minus 8x plus 12 plus x minus 1. I don't see any double negatives in this problem, so we can just go ahead and start by grouping up our x's. We have a 5x, we have a negative 10x, we have a negative 8x, and then we have a 1x. Okay. Now we can group the constants together. I see a 16 minus a 22 plus a 12 minus a 1. All right, now we'll combine that. 5 minus 10 is negative 5. Negative 5 minus 8 is negative 13. And negative 13 plus 1 is negative 12x. All right, now the second parenthesis. 16 minus 22 would be negative 6. Negative 6 plus positive 12 is positive 6, and 6 minus 1 is positive 5. So negative 12x plus 5. And that concludes today's lesson on simplifying algebraic expressions.